wait, 999
2x plus 1.
times 2x plus 1 to the 998. So remember what we did was we said, what's the derivative of a cloth to the 999? It's 999 cloth to the 998. All times, careful, careful. Remember, we did the 999. Derivative, what's in here? I heard it. 2? 2. Are we done? Times x squared. So this piece right here, that piece right there in blue is the derivative of this right here, including the 2. This piece is just the x squared. You got that? Now, I can factor that.
Where's the 2 from?
Where's the 2 come from? Okay, so remember the cloth? That 999 came out, and then we reduced the power by 1, and we were done with the 999, but then you have to uncover the cloth and look at what's in here and take the derivative of what's in there. The derivative of what's in there is just 2. Yeah? Got it? So let's see, do you agree that both of these things have a 2 in them? So this is equal to a 2. They both have a single factor of x, don't they? And this one has 998 factors of 2x plus 1, and this one has 999 factors of 2x plus 1, which means I can pull out 998 factors of 2x plus 1. And then what would I be left with when I pull those out? So what's still here once I pull out a 2x and 998 factors of that? Just one of the 2x plus 1s is left. What's still over here, if I've pulled out all 998 factors of this, I pulled out a 2 and I pulled out an x. 999 and 1x. 999x. And that's just, what, 1,001 x's plus 1? I think I see people tumbling off the bus here. What, you got to let me know. Are we okay on the derivative? Yes? So I'm just looking for GCF, a greatest common factor. I have 2 terms here, or 2, yeah, say these are 2 expressions, right? They both have a 2 in them. 2, 2. They both have at least 1x, 1. There's 2 factors of x. And they both have 998 factors of 2x plus 1. So I pull out the most I can pull out of both. And this is what remains. One of these factors is still here. Right? And then over here, one of these x's was still here, and the 999 was still there. Yes? So my final result is 2x times 2x plus 1 to the 998 times, I don't really need brackets, 1001x plus 1. That's the derivative. Cleaned up. Questions? You've got to practice, right? This is going to be one of the most important homework assignments that you do this semester. What do you see going on here? quotient rule? And a little chain in there too, right? The derivative of this should be the derivative of the top times the bottom minus the derivative of the bottom times the top all over, oh, this is good news, the bottom squared. That's the only good thing I've seen happen last 30 minutes, right? All right, can you handle this? Sure, this is just going to be rewritten. Derivative of the square root of x squared plus 1 is going to require a little bit of chain, right? So let's do this. Let's try and do it all in one step here. This right here is a 1. 1 times this square root. So there's just the square root. Minus, I won't use the magic cloth this time. I'll use the eraser. It seems a little more appropriate. What is the derivative of the square root of an eraser? 1 over 2 square roots of the eraser. 1 over 2 square roots of the eraser. Now what was the eraser covering up here? X squared plus 1. You've taken the derivative of the square root part of this, haven't you? So you've done this part of it. You still need to go inside and take the derivative of what's in here. What's the derivative of what's in there? 2x. And I put it here with what? Multiplication times 2x. Am I done? Times x. I got to finish off the quotient rule, right? This last x comes from here. All of this over x squared plus 1. I see some things that are going to be kind of nice. This 2 and this 2 cancel. Yeah. So I have. Were there any questions on where I got any of that? Just if you're sitting there going, I don't want to ask a question because I don't want to feel like I'm the only one here that doesn't get it. I'm sure you're not the only one here that doesn't get it. So any questions on where any of this came from? You see how I'm kind of moving through this kind of quick? Like if I were to have required, if it would have required me going over here and rewriting this and doing the f and the g and then the f prime and then the f prime of g of x and all that stuff that I started the whole chain rule off with, if I had to do that for that problem, it would just this would take me a lot longer, wouldn't it? We agree with that? How about a common denominator up top? Get these together like this. So I have to multiply top and bottom here by what? Square root of x squared plus 1. On the bottom, same thing, square root of x squared plus 1. When I put those two together, I get x plus 1, and then minus x squared, and then over the common denominator, and then all of that over x squared plus 1. The x's up there go away. I get 1 over the square root of x squared plus 1 over x squared plus 1. Anything you think I can do with that? I can flip this, okay? So we want to look at this as being like a fraction. So you get a fraction over a fraction. And so you can flip like that. So it looks like this. 1 over the square root of x squared plus 1 times that one flipped as 1 over x squared plus 1 like this. Which I could put these together and just put a parentheses around that and be done. Or I could also do this. Ooh, what happened there? Yeah, what's the power on this? Really, it's 1/2, isn't it? This is the same as this to the 1/2 power, isn't it? And then you have this to the first power. And then when you add the two powers, 1/2 plus 1, you get 3/2. So this is the same as this expression right here. Most likely, that's what would be in the back of the book. So imagine you go take your derivative and you had this thing that looks something like that, right? And you're like, yes, got it, like figured it, yes. And then you look at the back of the book, you're like, what happened, right? So you just got to get kind of comfortable with this sort of algebra in here. How you all feeling? All right. So I could show you 1,000 problems, and then you can be faced with one that you haven't seen. This is not going to be like I show you every single possible type of chain rule problem. It's not going to ever be like that. Every problem is its own thing, and so that's why when you get into the homework and you start practicing, you start to see, oh, wait a minute, I've got a product there, no, I've got a chain there, and you just got to really mess with it. I want to do one more where I set it up, but I don't do the whole problem because it'll just take too long. But just to kind of get you thinking about what you would have to do for something like this. Y equals the square root of x squared plus 4 over x squared plus 1. The what? That quotient, I agree there's a quotient there. Is it the last thing happening, though? The last thing happening is a square root, right? Something like that? What is the derivative of that green cloth? 1 over 2 square roots of what?
X squared
Of all that. So I put that in here. Am I done? Times. Now I've taken care of the root, haven't I? So now I have to find the derivative of what's in there. Now there's your quotient rule. Times, right, this part. What would this top corner be? When you take derivative, it'll be just 2x, won't it? Right now it's the x squared plus 4, then x squared plus 1, then x squared plus 1, x squared plus 4 over x squared plus 1 squared. Then you do all that and then have fun cleaning that up. You have one of these in the homework assignment, but it'll be an exercise in cleaning this up because this fraction, you can break this into 2 roots like this, and then you can flip it, and then you can start putting things together, and it's, yeah. Get the gist of that one? I think we'll do one more. And then I'll tell you what your homework assignment is, and then we're going to start thinking about something else. If y equals sine of x cubed plus 1, find y double prime. Find the second derivative, which means you need the first derivative, right? And then once you get that answer, you need the derivative of that. So what would y prime be? We have product rule, quotient rule, chain rule. What do we have here? Just chain, product, what is this? Just chain. Just chain. That's sine of x cubed plus 1, right? So it's just chain rule here. There's your little thing, right? Derivative of sine of that is what? Cosine of that. Then times the derivative of what I had covered up, 3x squared. I'll just rewrite it so that it's got the 3x squared out front, cosine x cubed plus 1. Any questions on that derivative? I hope that this whole little green cloth thing doesn't upset people, that you're not like, yeah, man, my freaking Cal teacher, he's sitting there, he's like, we got a cloth, a magic cloth, and that's how he's teaching us calculus. You know, like, I don't want it to be like that. I'm trying to give you a method that helps you go a little faster. I hope it does. If not, then you need to probably get with me so I can take you through and get you to that point where you're seeing these things without having to do all that F, G, H stuff, because that's tedious, very tedious. All right, that's the first derivative, right? Yeah. Second derivative, I'm going to have what going on here? Everyone see a product rule? Right there? The derivative of that's not going to be a problem. The derivative of this is going to be another chain rule. So since it's a product rule, I'm going to set it up like a product with those little parenthesis things. The second derivative will be equal to the derivative of this one, first one, times the second one, plus the derivative of the second one times the first one. Right? That's just writing out what the product rule is. Let's see if we can do this. All right, we'll go with this table. So this table up here is going to answer. Who wants it? 6x.
Cosine x cubed plus 1 plus negative sine.
Okay, so you're saying the derivative of cosine of something is negative sine
Sine x cubed
of that something
plus 1
times
squared
3x squared
times 3x squared.
times 3x squared. Perfect. That's it. Oh, I forgot one parenthesis right there because I had the negative out front. So right here required chain rule. I'm going to use my hand. Derivative of cosine of my hand is negative sine of my hand. Negative sine of my hand. Then, done with cosine, derivative what was there, which was 3x squared. I'm done with this, but then times 3x squared. Anyone disagree, or are we all good with that? All good? You could put these together, right? 9x to the fourth and a negative. So negative 9x to the fourth sine x cubed plus 1, 6x cosine x cubed plus 1. There's what, that's y double prime. Now, everything that we've done up to this point, as far as remember the whole idea was if you have a curve, you know, and you're trying to find the slope of the tangent line, then you have to find the derivative at that point, right? All we've done now is just expanded the types of functions we can find derivatives of. And in fact, there is no new rule, okay? There's no other rule when it comes to derivatives that we haven't looked at yet. So you should be able to differentiate everything with the exception of two types of functions, exponential and logarithmic functions, which we'll deal with that in a little bit. Okay, we're not going to deal with it now. All right? So like right now, we don't know what the derivative of e to the x is because it's not, right? E to the x, y equals e to the x. is not a power function, like it's not x to a power, it's actually something to x. It's an exponential function. So what's the derivative of that? Well, we'll deal with it, just not yet. But as far as all the other major rules, we've got them all. Like there's no other secret thing or... Now imagine, I just erased that answer, but imagine now you're in Cal 2 and you have to go backwards. So you remember you have to find antiderivatives in Cal 2. So you start with the derivative of something and try and go back to where it came from, which means you have to undo the chain rule sometimes. Can you appreciate how difficult that might be to undo the chain rule? That's what makes Cal 2 hard. With Cal 1, the rule's the rule. So like you do this, then this, then this, then this, and it just falls out. You know, the algebra sucks sometimes, but there's only one way to do chain rule. There's only one way to do product rule. But in Cal 2, it's just much harder to go backwards. So what makes a good Cal 2 student is a student who is good at the differentiation, right? If you can take derivatives really, really, really good, then you start to see them before you even write down the answer. You can see the chain rule and the product rule happening. If you can see all that, then when you try and go backwards, it's much easier to see. It's like anything else, right? The more exposure you have to something, the more practice you put into it, the more of an expert you become at it. All right, so for homework for this, let's see if I have the calendar or not. With me here. You can do everything on this sheet here. For 2.5, all those problems are doable. There is one problem on here, though, that I just want to give you a little guidance on, number 51. It says find all the points on the function f of x equals 2 sine x. It says find all the points. Oh, wait, there's more to that function, sorry. Plus sine squared x, where the tangent line is horizontal. What does a horizontal line have as a slope? 0. So they're really saying, where's the tangent line have a slope? 0, right? Which is really saying, where's the derivative 0, right? That's what they want to know? So they want you to take the derivative of this. Then they want you to set it equal to 0 and solve it. Which, if you take the derivative of this and set it equal to 0, you're going to have a trigonometric equation, which is something that you did in pre-cal. You have an equation that involves trig functions, and you try and solve it, and there's going to be a general solution. We might have to talk about that when y'all come back. Let's see, I've got a little bit of time, but I forgot my computer, and the thing I want to show, the next section requires that I show you something. So I want to just take this time, and you can kind of like exhale a little bit if you want. I want to just show you something that has to do with chain rule. It's just a different notation. Remember there was different notations for derivatives? I just want to show you a different notation, and it might convince you of why the chain rule works the way it does. So let's say that we had a function y equals sine of x squared plus 1. Right? I said in the beginning that we could break this down. When we were first learning about this, is like f and then g, and then in this case we would have what? F, g, h, and then, I don't know, k or something. We usually don't use I because we don't want to mix it up with the imaginary number. But we could do this composition of 4 functions, couldn't we? Yes? Yes. Okay. instead of using f of x, g of x, and things like that, why don't I do it this way? I'm going to say that y is equal to sine of u. U is equal to sine of v. V is equal to sine of m. And m is equal to x squared plus 1. Okay, so y is sine of u. So y is sine of u, but what's u? Sine of v, but what's v? Sine of m, but what's m? X squared plus 1. So do you see how that's basically going to give you the same exact thing, but instead of using f of x, g of x, I've got different letters? Yeah? All right. Now, using a different notation, what is the derivative of y with respect to u? So I'm looking at this equation here. Y and u are the two letters here. What is the derivative of y with respect to u? Should just be cosine u, right? What is the next one? What is the derivative of u with respect to v? Cosine v. What is the derivative of v with respect to m? Cosine m, right? And then lastly, what's the derivative of m with respect to x? 2x. Now what I'm trying to show you here, no one really asked why, is why does the chain rule say that you do the derivative of the outer one and then times the derivative of the next one in, then times the derivative of the next one in? And why is it times and not plus or something like that, right? This hopefully will convince you of why that's true. So now, I want to know the derivative of this, right? I want to know what dy dx is. I want to know the derivative of y with respect to x, because x is my variable. Do you agree that this would be the same as dy du times du dv times dv dm times dm dx? Because these would all cancel and you would get dy dx? Yes? So if I take this times this times this times this, that should be the derivative of this, which for us in this problem would have been what? Dy du, which would have been cosine u times what? Cosine v times cosine m, cosine m times 2x. Now this is where things get a little more complicated. Cosine of u, but what's u? Cosine of v times cosine of v times cosine of m times 2x. Now, what was v? Sine of m, right? Wait. No, v. Sine m. Oh, yeah, okay, you, hold on. Y'all told me it was cosine. It's actually what? Sine, sorry. Okay, so this should be cosine of sine of, and what's v? Sine of m times cosine of v, but v was sine of m, and then cosine of m times 2x. And now I go and I replace all my m's with what? X squared plus 1. Okay, so this is going to be cosine of sine of x squared plus 1. Going crazy here. One more parenthesis. Cosine of sine of x squared plus 1. And then cosine of x squared plus 1 times 2x. All right. Now, that should be the answer, which we could do if we covered up everything in there, right? The derivative of that is what? Cosine of this, and that's right here, cosine of the green thing covered up, right? So I'm done with this. Now, derivative of sine of this is cosine of that. That's this piece right here. And then derivative of sine of that is cosine of it. And then derivative of the inside is this. All this was, the only reason I put this on the board is because I wanted you to see, to convince you of why it's times, times, times each time. Because it really comes kind of from this idea, if that makes sense. All right. I guess you're going to have a good weekend doing nothing but chain rule, right? We need to take a quiz, but we're a week behind, so I'm like, the quiz is going to take 20 minutes. Just so hesitant. Unless y'all want to turn in your chain rule homework for a quiz grade. An effort grade. Let's do that. You do as much chain rule as you possibly can between now and Monday, and we'll turn in that assignment as a grade. I won't be checking it to see, did they do every problem? I'm going to check to see, I want to see your work. I want to see your handwriting. I want to see the way that you are working things out. I don't want to see the answers from the back of the book written down, numbers, 1, 3, 5, 6, and you just write all the answers. That's not the point. All right? It's an easy quiz grade if you just go home, make an honest effort at it. All right. Have a great weekend. The chain rule.